In this video, we are going to go over creational design patterns considering you're a beginner. What is a creational design pattern? To understand that, let's understand what design patterns are and why they exist. The term design patterns was coined by Christopher Alexander in his book A Pattern Language, but the term really gained attraction in the book Elements of Reusable Object-Oriented Software, which was written by the Gang of Four. This video is loosely based on that book, so if you want to go ahead and know much more about all the design patterns we are going to cover, link to buy the book is in the description of the video. So let's get to the question, what are design patterns and why you should care about it? Let's take an analogy to understand this. Imagine you're a chef and you just opened a new restaurant. A critic comes and tells you that your food is trash, so you start to work on improving the food quality. If you're improving the quality, it means you keep on trying something new every single time you cook. The first time you try adding less salt, second time more spice, and so on. You record all the recipes you cook. Finally, you get the desired taste, so you stop improving the food quality. This analogy in terms of code is exactly what a design pattern is. Suppose you encounter some coding problems again and again in your project. Being a programmer, you don't want to rewrite code. You believe in dry principle, meaning don't repeat yourself. That's when you use these design patterns. If you've coded on a big project, you've probably even used some of the design patterns we're going to take a look at. They can be considered as basic vocabulary to talk about a problem and a solution. So if a programmer wants to communicate with another programmer about a solution to a certain problem, they can just say, let's use Singleton instead of saying, let's make sure that a class has only one instance available throughout our codebase. These design patterns not only help in communication in person, but also in code, meaning they improve the code readability and provide with tested effective solutions, eliminating the possibility of having poor software design. I'm saying this because the design patterns we're going to take a look at in the future videos are being used for more than 3 decades in different object-oriented programming languages. And it's hard to find an object-oriented system that doesn't use at least a couple of the patterns you're going to take a look at, if not all of them. The design patterns are segregated in 3 parts: creational, structural, and behavioral. We will understand creational design patterns in this video, and in later videos we will explore the remaining 2. There are about 23 design patterns, but you can expect 3 videos in total. This is the first one covering creational design patterns that are concerned about how the object is created. We will break this definition down towards the end of this video once we've looked at all the creational design patterns. For now, let's start with the first one. Singleton. Singleton is a creational design pattern that ensures a class has only one instance and provides a global point of access to that instance. Let's take an analogy. You can think of Singleton design pattern as having only one principal's office in a school. Just as there's only one principal who manages the entire school, a Singleton ensures there's only one instance of a class that controls access to its resources. By resources here, I mean variables, functions, and other attributes that might be present in a class. Imagine if every time you needed to talk to the principal of a school, a new office was created. Where would you go? It would be chaotic and inefficient, right? Similarly, the Singleton pattern prevents multiple instances of a class from being created, ensuring that there's a single point of control, just like the principal's office is a single point of control in the school. Let's dive into the code to understand this better. Let's say we have a Flutter application like this over here. So we have a main function where the run app is being called, then we have a my app class where login screen is the home screen. And in this login screen, what's going on is that we have 2 controllers, email controller, password controller, to take in the inputs from the UI. So we have that over here. And then we have an elevated button, which when clicked on, calls the handle login function. And this is the handle login function. Let's say we have a variable that comes in through the API call of the user ID. So what we do is log in with that user ID, right? And to log in, what we call is user session.login, and that is this class. So user session is a simple class which has the attributes of user ID, is logged in is equal to false, the user ID getter, because this was a private variable, right? So I have a getter outside, and the reason this is a private variable and this also is a private variable is because I don't want it to be accessible outside of this class. That means if you want to change the user ID, you'll have to change it within this class, not outside of this class. And that's quite important. But if you do want to access the variable, not change it or modify it, if you just want to access the variable outside of the class, we have a getter for that. That's why we have a user ID and is logged in variable like this. After that, we have a function of future void login. What it does is set the private variable of user ID, which is present inside this class, to the user ID that we're getting from the function parameter. Then it's setting is logged into true because now we're logged in. And then we're simulating an API call of storing to a secure storage service. For example, you might use shared preferences or Hive or whatever you want to use to store it locally in your system. We also have a logout method. All it does is that it sets the user ID to null, is logged in to false, because if you log out, you're not logged in. Simple. So that's what this handle login function does. Just call the login function, which creates all of this thing. Now, what are we expecting? Well, we are expecting that if I log in, let's say XYZ and my password is test123, I click on login. Well, as you can see, it logs me in, but the user ID is not available. Why is that not available? Well, let's debug it. If I go to the profile screen, we have user ID printed out over here. By the way, this is a profile screen, all right? The previous screen was login screen, which was this one, a simple 2 text field and an elevated button page. And this one is a profile screen with a text and an elevated button. So what we are doing here is getting the user ID. And how are we getting that? Well, we are doing user session dot user ID. And if that's not present, then it's not available. And we are seeing not available. That means user session dot user ID is null. Well, let's go into the user session variable and see what that is. Well, it's a new instance of the class. And since it's a new instance of the class, when this function is called, it means we go over here at the top and we re-instantiate this class. So that means user ID is set to null. So every time you call user session like this, it is always going to create a new instance of the class and it will re-initialize all the variables that are present. So it re-initializes user ID. And that's why we get a null attribute over here. To explain this better, let's go to the diagramming tool and draw this out. So let's say this is the login screen and this is the profile screen. In the login screen, what we did is clicked on the login button and it called this function. So what happened in the handle login function is that we took the user session and created a new instance of it. So we have all of these properties. This user ID is logged in. We took all of this and set it as it is to their default values. All right. After that, we called the .login function on that particular instance. It's the same instance where we called the login function. So we went over here and set the user ID to the new user ID. And this was the user ID that we passed in, user123. So what it will do is in this instance, it will set the user ID to user underscore 123. And then it set is logged in is equal to true. So it's not false anymore. It is true. And then it's saved to secure storage. And that's why we get simulating save to secure storage. But when we go to the profile tab, this profile screen, what's happening is that we're creating a new instance of user session. So you remember all the old values that we had? The string user ID was nullable. No default value was given and is logged in was false. So this was re-instantiated. And then we simply called the user ID property on it. And that meant that this part is null. So the user ID is null, so we get null. And that's the problem that we want to fix with Singleton. In Singleton, we won't have a separate instance of user session. Every time we call user session, the same instance will be used. So what we want to do is eliminate the creation of another object. We'll remove it, and this will be the one and only object that can be created out of user session. This will be the single source of truth. So how do we implement that in code? Well, to do that, we can think about it logically. How can we avoid the creation of multiple user sessions every time? Well, we know the answer to that. This user session class, whenever it's called like this, it is going to create a new object. So what if I don't allow the creation of an object like this? I just block it. So the user will never be able to do this. And that's what we're going to do. Privatize the constructor. So to do that, we can just do user session dot underscore internal. And with that, we have privatized the constructor. So if you want, you can print it over here, privatized the constructor, or you can just say private constructor ran, whatever you want to call it. But if we do that, we'll have multiple errors in our application, and you can see that over here. The first time we want to create an instance of user session, it won't be created because we are just disabling the user session to be called this way. So to fix that, we can give an access to an instance from inside the class. So what we're going to do is we're going to provide access to the instance of this class by doing final user session, because we are going to give access to this particular class itself. And let's call this underscore instance is equal to user session dot internal. You cannot and should not call this particular attribute from outside the class, but you can call it inside the class. And now we have an instance created that we can use outside, but obviously this is a private variable, and it's for a reason, because I don't want it to be changeable or modifiable from the outside world. Just like we have for user ID and is logged in, they're all private so that they're not modifiable from the outside. We're going to do the same thing. We're just going to give access to this user session through a getter. So we are going to have get instance and then provide access to this underscore instance. And with that, we can go ahead and fix the errors over here. Instead of doing user session like that, we're going to do user session dot instance. But you might notice that we're not able to call instance. Why? Because when we create a variable like this, user session get instance, we are still expecting this to be called on the user session object. So to access this instance method, what you'll have to do is user session dot instance. But we have disallowed the usage of user session, so we cannot do this. What we'll have to do instead is just add a suffix of static before everything. So in these two variables, we are saying that these things are accessible without the creation of object. So we can just use it like this, user session dot instance. And with that, it was going to work. So let's go down and you'll see the error is fixed. We can go down here as well and we'll have user session dot instance like that. And there we go. Quite easy, right? So we can now reload and run everything. Let me pass an XYZ test123. We'll click on login and we have a user ID user123 showing up. As you can see, private constructor ran. The private constructor first ran when we wanted to log in. So we created user session dot instance. And then we had simulating save to secure storage, which was just called after the login function. After that, let's say I decide to log out. Well, what do we expect? In logout, what are we doing? Well, we're doing user session, which is user session dot instance dot logout. So that would mean the private constructor should not be run again. Isn't that right? Because only one instance should be created. The first instance is already created, so the private constructor should not run. And if I log out, that's exactly what happens. The private constructor does not run again. If I again try to log in, and let's say I click on login, it only printed out simulating save to secure storage. The private constructor only runs once. The first time the instance has to be created. Now, before we move to the pros and cons of Singleton design pattern, I would like to show you one small thing. And that is, what if this was directly made a getter? You did not have this two lines, only this was made a getter. Because I'm sure you might be thinking, hey, why do you need two lines when we can only have one? Well, I wanted to show you the effect it would have. So let's say we have static user session get instance and it returns user session dot internal. Everything will look the same in the code, it will all work out, but the problem will come in over here. Let's say I type in XYZ test 1, 2, 3. Well, I got that wrong, but okay. So the user ID, as you can see, is not available, and we can see the problem. The private constructor runs the first time, then it simulates, and then it runs another time. Why? The problem was that the private constructor ran 2 times. In our case, what happened is that you logged in. So that was the first time private constructor ran. Then it did the simulation of save to secure storage. And after that, we moved to the profile screen. In profile screen, we had user session.instance created in the build function. So when it was building the UI itself, it ran another time. So the private constructor ran. And because of that, we have a new instance of user session, not the same instance. So again, 2 instances were created, and it's only because every time you access this instance, it calls user session.internal, and we don't want that. We want to call it once and use it every single time, and this logic helps us do that. If we just do get instance underscore instance, it will always access this particular instance of user session.internal, which is only created once, because this class is only going to be run once. Okay. So that was one small thing that I wanted to show. And now I would like to show you the UML diagram of Singleton. So we have a static instance which just returns a unique instance. That's what a Singleton does. Every time you contact a class, it is just going to return a unique instance. Nothing else changes. All right. The pros of Singleton are that it's a single source of truth, as there's only one point where you can get the information from about the class. Another pro could be that when you're managing shared resources like database connections in your application, let's say you made a database connection to your PostgreSQL database. Now managing those shared resources can be easier with Singleton, because instead of connecting to your app every time by calling a non-Singleton class, you can just make it a Singleton and you're guaranteed to only call it once. If you followed any of my project videos before where we dive into WebSockets, you might have noticed we use Singleton over there. And the reason we use that is because we only want one connection in that app, and Singleton allows to do that. And as a fun fact, behind the scenes, you'll see Firebase uses Singleton for all of their packages. You remember when we use Firebase auth.instance, that's a Singleton. Or Firebase firestore.instance, that's a Singleton. The cons of using Singleton are that it's harder to test Singleton classes for 2 reasons. First, it would be difficult to replace the class. Let's say the user class session present here, we'll have to replace that with the mock class. So we'll have to write an entire mock class, because we can only access this user session by doing user session.instance. We're not creating an object of this class, else it would be much easier. Second reason it is difficult to test is because it is a shared resource. Think about it. You run a test, you affect the data that's present in the Singleton class in this test. So if you had a test of logging in the user, you've affected this user session class, and the variables here have changed. So the user ID has some value, is logged in has some value. Now you run another test. Since it's a Singleton, it's not going to reset the attributes like a normal class would. The same instance is used. So this instance where the data attributes had been changed is going to be reused. And this might interfere with the fundamental principle of testing, that they should be written in isolation from each other. Every test should be independent from each other. The third con is that the Singleton class remains alive until the application terminates. So if the Singleton class consumes a lot of memory or a lot of network, it wouldn't be a good thing. The reason the Singleton class remains alive until the application terminates is because we saw over here that if login screen was using user session.instance, even profile screen was using it. So this Singleton class always has to be alive for as long as the application is alive, because it can be used anywhere, and we want to persist the state of that object that's created once. Because it should be accessible in this class, it should also be accessible in this class. So if the Singleton class consumes a lot of memory or a lot of network, this really wouldn't be a good thing. Generally objects just die with the class. So if this class is moved on to another class, every object that's used is going to get disposed of except the singleton. So that's one thing you need to keep in mind. I wouldn't exactly call it a con. It's more like a trade-off. So you'll have to keep all these things in mind, and it's quite logical. This is it about singleton. Now let's move on to the factory method pattern. So factory method pattern's definition is that we define an interface for creating an object but let subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. What does that mean? Again, let's take an analogy. Suppose we are working in a factory and a higher position person comes to us and says that the factory is starting a hiring round, and in that hiring round, you are giving the responsibility to hire a person based on their good programming skills or good leadership skills or anything. So now you're given a list of people, and from that, you need to select the best one. So just observe what I said. I said you're given a list of people, so you just can't go outside and select people based on your preferences. Those selected people are like a filtered list. They're filtered from the top of the management based on where they live, if they're going to do remote work or not, their qualifications, etc. Now your work is just to see their programming skills and based on that return a person who's the best at it. You don't care about their qualifications or anything, and you're not even going to ask them what their qualifications are. That was for the recruiters to do their job. For you, it's just selecting based on their skills. That's exactly what factory method pattern is. Let's revisit the first line of the definition. Define an interface for creating an object, and let subclasses decide which class to instantiate. We are the subclass in this factory, and we are going to decide which person we should return, so that means we are going to decide which class to instantiate. Now, let's go ahead and understand this code example, implement the factory method pattern here. So what I have in this code is a MyApp class where a payment screen is being returned. In this payment screen, I have a variable of isProcessing. This is used to show a loading indicator of some sort. Then we have a function to handle a payment. And we support two types of payments and actually three types. Pay with credit card, pay with PayPal, and the third one is Apple Pay, but you can't see it because you can't see it on Chrome, right? But I've just added an if condition for that place. If theme of context.platform is equal to iOS, then we're not going to see the elevated button for Apple Pay because it's not supported on Chrome. It's supported on Safari and iOS. So yeah, now notice what's happening in this handle payment function. This function is used for any of the payments. So if I click on this button, pay with credit card, this function will get triggered. If I click on pay with PayPal, this function will get triggered. And for Apple Pay as well, this function will get triggered. So it's a reusable function handling all the payment methods. So what it's accepting is an enum. An enum meaning this thing. It can have three options: credit card, PayPal, or Apple Pay. So now, based on these conditions, we need to decide which method to call, right? There'll be a function to pay with credit card. There'll be a function to pay with PayPal. There'll be a function to pay with Apple Pay. So based on this enum, we are going to decide that. Now, your first instinct would be that it's way too simple. If method is equal to, let's say, payment method dot credit card, let's say, then we are going to call the credit card function. Otherwise, we are going to check if the payment method is equal to PayPal. Then we'll call the PayPal method and then Apple Pay. And essentially, the core of it is that the logic is going to remain the same, but the way we do it is going to differ because that's what design pattern is for. So again, coming back to the definition, we are going to create an interface and let the subclasses decide which class to instantiate. So first of all, we are going to create an interface. So our interface is going to be, let's say, abstract interface class payment processor. And if you're wondering why I've used abstract interface, it's because I want a true interface. If you just use abstract class, it won't be a true interface like in other programming languages. You have to use abstract interface. If you want to know more about these keywords, I've created a whole video on Dart 3, which covers all of these things. All right. So now in this interface, we're going to have two functions. The first one is going to be the process payment function, and the second one is going to be a simple function that just returns the payment method we are going to use. We are adding this just so that, there's more functions and you get the understanding of how it would be implemented in real life. So the first one is future Boolean. Boolean we're returning because we want to tell if the payment was successful or not. So we are going to have process payment, and then we're going to take in an amount. So for how much money are we doing our job for? And the second one is going to be a future, not future, let's just return a string, and it's going to be get payment method. So it's just going to return in a string format, is it credit card, PayPal, or anything. I don't know, generally you wouldn't probably have this, but you might have other functions, and this is kind of a mock of those functions, that you'll have other functions. This just denotes that. Consider it like a filler code. So now that we have an interface created, we are going to create 3 separate classes. One is going to be the Apple payment processor, then there's going to be credit card processor, and then the PayPal processor. So let's go ahead and create, let's say, credit card processor, which implements payment processor. And we are implementing so that, we can later on override these 2 methods that are present. So I'll just press command full stop and create 2 missing overrides. Then we can implement the payment method. For credit card, maybe we can just write print processing credit card payment of, and then we can have an amount. So let's take in an amount, and actually this is not the correct function. We need to do this in process payment. So we are doing it for amount dot to string as fixed and then 2. So it will show the amount up to 2 decimal places. After that, we can just have await future dot delayed, and we can add a duration of 2 seconds. And this is also going to be an asynchronous function because we are awaiting over here. So this line is just simulating how a real credit card processor would work, because it would talk to the external APIs, maybe using Stripe or something like that, and just make it work. So this is just a mock value, and then we can simply return true. So with this, we have a process payment. If you want, you can add another print statement here that, hey, we're using your card, asterisk, 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 and then pass in the card number or something of that sort. And you also take the card number from the constructor of this class, but I'm not going to do that. Here, we are simply going to return credit card or whatever you want to return. As I said, this is a mock function. It doesn't really carry any purpose. Then we can copy this and paste it again, this time to create a PayPal processor. Then we are going to return PayPal from here. Then we can say processing PayPal payment of whatever the amount is present. And then we can also have a print statement saying that, hey, we're using this PayPal account. And then if you want, you can take the email or the token or whatever is required for PayPal from the constructor again. Then again, we're going to create it for Apple Pay. So we're going to have Apple Pay processor. Here we're going to return Apple Pay. Then we're going to say processing Apple Pay payment of whatever. And yeah, so currently only this line changes, but you can assume in a real application, things are going to look much more different. You're going to take different things from the constructor. For Apple Pay, you probably need the email of the user. For PayPal, you need the email and the token. For credit card, you need to take the credit card number or the secret number, or you have to call some other API. All of the things are going to change. As of now, only the print statement is changing. But anyways, the core of it is that we have all of these classes. So technically, these classes are not really subclasses. They are implementing. If you extend a class, it's going to become subclasses. So if this class had extended this class, then it would have become a subclass. But as of now, we are implementing. If you want, you can extend this as well, and it should work quite similarly actually. So yeah, but I prefer to implement because we want to implement these methods, right? I want to be more explicit about it. So now that we have all of these classes, what do? Now we need to decide which function should get called when. And you can implement this in here, but that's not a very clean way of doing it because you're scattering your logic all around the place. What you want to do instead is just implement it in this payment processor interface. How? you can create something known as a factory constructor. Now you might ask, why are we using factory constructors instead of using normal constructors? And the thing is, normal constructors don't return anything. They allocate memory and initialize fields for the class they belong to. That's it. They don't return anything. Factory constructor, on the other hand, will allow you to return instances of the class, instances of the subclasses, and that's what we are trying to achieve. That's why we are going to use factory payment processor. And from here, we are going to take in the payment method. So we are going to have payment method, and then we can have a switch case or an if else or whatever. And it's going to be that, hey, if the case is, let's say, payment method dot credit card, then we are going to return the instance of the credit card processor. So we are going to have return credit card processor. And if you have certain instances, like for example, if you're taking in the card number from the user, you're going to pass it through here, and you can also take it from the constructor. So let's say you have certain fields like card number, email, token, whatever we had decided to return from PayPal or Apple Pay or anything, you can take it from here. For example, if you had card number, you could take it here and make sure it's nullable, because card number is required when you're returning the credit card processor, but it's not required when you're doing PayPal processor. So it shouldn't be required fields. It should be something like this. Okay. But we don't have support for that. So we are just going to return a class like this. The second case that we're going to have is payment method dot Apple Pay. Then we are going to return an Apple Pay processor. Let me find that out. Yep. And the final case is going to be payment method dot PayPal. Then we are going to return the PayPal processor. Let me find that instance. And we're going to return that. If none of these cases match, then we're going to have a default one. And in that case also, I'm going to return the credit card processor, the default thing to do. But as you can see, Dart is smart enough to realize that this default clause is covered by the previous cases. So we can just remove this. So yeah, with this, it all worked out, but we have errors down there. Why are we getting this error? That's because we have a factory constructor replacing the traditional constructor, or the real constructor, so to say. Now, when you extend a class like this, Dart goes looking for a real constructor in payment processor, because it needs to call it using the super method. If you remember, there's something known as super. So like if you extend a class, you get access to that super. And what that super does is call the parent class, which is the payment processor. But here it doesn't have that constructor. So it can't call super, and that is why we're getting this error. So to fix this, we'll have to shift to implements. So yeah, let's go ahead and do that, and it will work out, because in implements, it doesn't have to call the super class, and it doesn't have to call the super class because it's not inheritance that's happening. It's not subclassing. It's just implementing the methods that are provided here. So I hope that's clear. If you have any questions, let me know in the comment section, or you can always ask ChatGPT. Now the next thing I want to do is call this payment processor somehow in the handle payment function. And that's quite easy actually. All you have to do is first create a processor, which is equal to payment processor. And then we can call it like that because we have a factory constructor. Then we can pass in the payment method. All the logic of what payment processor to decide is created in here. And then we can simply call in processor.process payment. Then we can also await this and get the Boolean value that if it's a success or not. So we can just store it in a variable of is success. Now process payment requires us to pass in the amount, and for the amount, maybe we can just hard code it to be $400 or 400 rupees or whatever. Then we can just say if it is a success and the widget is still mounted, then we can display a scaffold messenger dot of context dot show snack bar that, hey, we have a success, let's go. Then we have a content of text saying payment successful, or if you want to make this more fun, you can simply do $processor dot get payment method payment successful. So now we have made sure that the function we implemented for no use is now of use. Yeah, that sounds good. Now we can pass it in over here, and I believe that should work fine. In case of error, we have caught it successfully. Even and finally, we have caught it successfully. So yeah, all the parts are there. Now we can run this. Let's click on pay with credit card. 2 seconds, and then it says credit card payment successful. Let's say pay with PayPal. Yeah, processing PayPal payment of 400. So yeah, everything works out. Now, if you want to test out the iOS one as well, you can definitely do that by commenting out this line, pay with Apple Pay, and we're done. Yeah. So yeah, that's great. Now you might wonder, why do we need to do all of these things? It just feels like additional load and burden of code. Like, all of this could have been prevented by just implementing all the logic here. And that's right, you could do that. But following the factory method pattern provides us with some advantages. For example, it promotes loose coupling, meaning the components of a system have less dependency on each other. In our case, our payment screen only interacts with a common interface rather than each of the processor classes, which makes the code easier to maintain and extend. For example, now if I want to add some other payment type, maybe Cash App or some other thing, what I need to do is go to this class of payment processor, and here add a case of payment method dot whatever the new method is, and then I can return the processor, which is completely independent of this code. I don't have to touch the other processors like PayPal processor, Apple Pay processor to change or to extend functionality to this code. And it follows one of the solid principles. If you want to know more about solid principles, I've created a separate video on it. Specifically, it follows the O in solid principles, which is the open or closed principle, meaning that the classes should be open for extension but closed for modification. So we are extending a new feature by not changing any of the other classes, and that's good. Because let's say if we had to change a class, we could have written something that would break the entire system, because there's always a possibility in complex software. So this helps. Now that's the advantage part of factory method, but there's also disadvantage. The pattern introduces additional classes, abstraction, and that's just more complex code. For small or straightforward applications, this is unnecessary complexity for sure. So if you're working on a software that's going to be there for, let's say, 5 years, I would recommend using it, but for a simple application, don't over-engineer it. The second con is that in some cases, the factory method pattern might not provide enough flexibility for complex object creation. So as of now, we have quite a simple thing. We just have credit card, Apple Pay, PayPal, quite straightforward. But sometimes the object creation logic can be more complex, and that will lead us to abstract factory pattern. And we'll talk about that next. But before we go there, I would like to tell you something about factory method pattern. Now, if you remember the definition again, factory method means to define an interface for creating an object, but we let subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. In our case, subclasses, and they're not exactly subclasses, we've talked about that, but let's just call them subclasses as of now. They're not deciding which class to instantiate. Instead, the parent class is deciding which class to instantiate. The interface is deciding. So is that factory method pattern? Well, yes. In the traditional factory method pattern, the base class, which is this one, the interface, would define an abstract method called create processor as well. So instead of having a factory constructor here, you would have a function called create processor. And these subclasses or these classes that implement this payment processor would override the method of create payment processor. And then the subclasses would decide which concrete class to instantiate, right? So does that make our method incorrect? No. Why? The principle of deferring instantiation is retained. The client, which is the payment screen, this code right here, this is called the client. This does not instantiate objects directly. It relies on the payment processor interface, which decides which objects to instantiate. So the payment screen defers the instantiation of objects to the payment processor interface. And this gives us a centralized logic of instantiation decision based on a strategy. And the strategy in our case was to use the payment method enum, which is this part over here. This was the logic or the strategy to decide which class to instantiate. So it does fulfill the intent of the factory method pattern. And for all the people who love diagrams, this is a very simplified diagram of what's happening. Well, we have our payment screen here. The payment screen is creating an instance of the payment screen state. So this is Flutter related client code. Now this payment screen state, what it's doing is having two functions. It's having the handle payment function, which is bound to the buttons. So whenever we click on it, these buttons call this function. And then there's the build function to build the UI. Now this client uses payment method enum, which has credit card, Apple, PayPal Pay, all of these things. And it creates payment processor interface. And you can see we have a process payment, get payment method, these two functions, and a factory method constructor. In our case, we are only taking the payment method from the constructor, but as I said, you can always take card number, email, token, whatever. Now we have three classes or three ways of implementing payments, which is credit card, PayPal, and Apple Pay. They all implement these interface, and then this payment processor decides which one to instantiate. So if you see, the client only interacts with this payment processor. It doesn't interact with these three classes, and it doesn't have the load of these three classes as a result. Its logic is quite simple. All the main logic goes into this interface, and that's good code. So yeah, this is the factory method pattern. As I said, abstract factory is often implemented with the factory methods because factory method pattern might not provide enough flexibility for complex object creation logic, which we'll explore in abstract factory. So let's get into the abstract factory pattern now. So what is abstract factory? Abstract factory's definition is that we provide an interface for creating families of related or dependent objects without specifying their concrete classes. Again, let's just take an analogy because the definition is quite too complex to understand without an analogy. So we're going to extend the analogy we used in the factory method pattern about us working in a factory and being given a filtered list of candidates. Now let's say our company is expanding to different regions and different job roles. The company needs to set up multiple hiring teams for different regions like Asia, Europe, America, etc. And different roles are also needed like developer, designer, manager, etc. Each region and role might have its own way of filtering candidates based on local needs or specific skill sets. That's when an abstract factory approach can be useful. You will now have a hiring department for each region and role. For example, you will have an Asian hiring department, European hiring department, and an American hiring department. And within each of these departments, there will be more divisions based on roles like developer hiring team, designer hiring team, manager hiring team, and so on. In each hiring department, we will have a factory responsible for filtering a list of candidates based on regional preferences like language skills, location proximity, work culture, etc. If you notice, each hiring team inside a department has a specific factory method for evaluating and selecting a candidate. So I think the difference between abstract factory and factory would be visible now, but let's make it clearer. What is the difference between factory method and abstract factory? Factory method is like a specific hiring manager choosing the best candidate based on a specific skill like programming. But abstract factory on the other hand is like the higher level system that sets up different hiring managers for different regions and different roles. Now, if you again remember the analogy I had used in factory method, I had said that the higher position person comes to us and says that the factory is starting a hiring round, and in that hiring round you are given the responsibility to hire a person. That higher position person represents abstract factory pattern. So having understood that, let's dive into the code to get things clearer. Now we're going to use the same example of payment method that we have, but now what I want to do is also display a widget specific to each of these things. So if the user clicks on pay with credit card, I want to show an input for credit card. So I will have to accept, let's say, credit card number, CVV, etc. So that UI, the UI for credit card, is going to look different from the UI of PayPal or Apple Pay, because both of them are only going to have one button. But the button styling is going to be different. For example, you know how a PayPal button looks and Apple button looks like this. So we have different designing to do. So this is where an abstract factory can help us. Now you might be wondering, we can just add that in the credit card processor, right? So if we want to create a widget, we can just have a widget over here that will create, let's say, a payment validation widget. So we can just have widget, create payment validation widget. And you're right to argue that. You can do that and it will work out, but this is not good code. And the usage of design patterns is for writing good code. The problem I have with this code is that credit card processor should only have details about credit card processing. It should not have details about UI, for example, or if we want to implement something else, let's say logging, or we have some other feature. All of those should be in separate classes of their own. Credit card processor should only be used for credit card processing logic, nothing else. So in a real world scenario, let's say this can be a class that only interacts with the credit card processing logic, the API present for credit card processing, nothing else. So you might have helper functions over here, which can be called in this process payment, and this process payment can be used in some other class. But I'll emphasize again, this class should only contain the logic for credit card processing, nothing else. All the UI or let's say any other feature you decide to add should go in another class. And if you create that another class, you need an orchestrator class, which will be the abstract factory. What I mean by that is at the top, just below enum payment method, what we are going to do is add a new interface. So we are going to have abstract interface class. Let's call this abstract payment factory. And within this, we are going to have two functions. The first one is going to be widget create payment validation. Let's just call it that. And we are just going to take in a build context because the work we are going to do is going to require the build context. And the second thing that we are going to need is, well, the payment processor. So remember, this is the class. All of this logic is creating the payment processor, but this is the abstract payment factory class that is going to interact with our UI. So we still need to call the payment processor over here. So instead of calling the payment processor like we did in the handle payment, we're going to call it in this class. You can think of this as a super class or an orchestrator class. This is going to be the interface we are going to interact with instead of this factory method abstract interface that we had created. So let's have payment processor, which will be returned from here, and call this create payment processor. And similar to this payment processor, we are going to have a factory constructor to decide which class is going to be instantiated. And based on the payment method, let me just fix this. Based on the payment method, we are going to decide which factory class to return. And the factory class that we want to return, well, we'll have to create it first. So we are going to have class, let's say PayPal payment factory, that is going to implement, just like we did before, it's going to implement the abstract payment factory. So let me just take that. And then we are going to have an overriding method, or actually two of them. And in this one, what we are going to do is just return a credit card processor. So we are going to have return, or let's just say PayPal processor, sorry about that. And then we have to create a payment validation widget. Now, the payment validation widget can be created in another class, just like we did with this factory method. So we have the PayPal processor that we had created, which we are using over here. Similarly, you can do the same thing for the UI, but I'm not going to do that. I'm going to save some time and simply return a text form field. Obviously, good code would be doing this in another class, but I just want to save some time. You get the idea. Then maybe you can add some decoration over here. Let's say it's going to be a constant input decoration. Then we're going to have a label text of, let's say, enter CVV. Then you can add other things like border, all of those things, but I'm not going to get into the designing part. The point here is that the PayPal payment factory is created, which I'm going to return if the payment method is PayPal. Done. Now, similarly, we are going to do it for the Apple Pay and the credit card. So let's have a credit card payment factory, and actually enter CVV is in the credit card payment factory, not in the PayPal one. In the PayPal one, you need an elevated button. Sorry about that. So we're just going to go over here and change this to elevated button. And then we can just have an on pressed and then a child. And in the child, we can just say constant text validate PayPal account. And in the on press, maybe we can have a scaffold messenger saying, yeah, you did this work. Good job. So yeah, let's just show a snack bar, and the content here is going to be text validating payment credentials. Let's just add PayPal credentials. All right. So this is done. I'll just take this elevated button so that I can use it in the Apple Pay as well. So we'll have Apple Pay payment factory. And then I'll just return this button, but I'll just say validate Apple account and validating Apple payment credentials. And that's it. I'll just copy this Apple payment factory, return it in case it is Apple Pay, and then the credit card payment factory over here. Also make sure you change this processor. So you're returning credit card processor. Here you have to return Apple Pay processor. And that's pretty much it. So this is abstract factory. Now what you want to do is just use this abstract payment factory that you had created instead of using the factory method earlier. So in the UI of payment screen, we had final processor is equal to payment processor. Now we are going to have abstract payment factory. That's it. Abstract payment factory. Now with us, we have a factory. And that factory can call any of the payment methods, and all of those payment methods have a UI widget attached to it and the actual processing logic. So we can use either one of them. If we want to compare it to our analogy, now we have the entire company's access to us. Now we can contact each of the hiring departments, like the Asian department or the European department, and then use it. So after this, we can simply create a processor. So we'll have final processor is equal to factory dot create payment processor. Now we have access to the payment processor, which can be used over here, and rest everything works together. So all we had to do was create this factory and access the processor on it. Now, if we want to get access to the UI, we can do that as well and display it on the screen. For that, we'll have to change things a little bit. First, we'll have to add a widget that can be null, and let's call this validation widget, right? Now this validation widget can be used over here. So validation widget is equal to factory dot create payment validation. Then we can call set state on this so that the validation widget can now show up on the screen. And now at the bottom, or on top of this, I don't know, we can here add if validation widget is not equal to null. In that case, we are going to call the validation widget like this. And as you can see, we get an error. The element type widget question mark can't be assigned to the list type widget. I'm just going to add an exclamation mark because I just checked if validation widget is not equal to null. So yeah, we're good. Let's put a comma, and I think everything should work. Let's run. And we have an error. One positional argument expected by create payment validation. So here, what does it need? I think it requires context because we said we'll pass in the build context. So we can just pass it in like this. Since we are in a stateful widget, we get access to context from the state. So we're good. We can run this, and yeah, let's see. We have pay with credit card. Let's click on that. Well, it does give us enter CVV and then credit card payment successful. Now, if you want to change things, we can obviously go ahead and change it. For example, we first want to get the CVV and then we want to process the credit card payment. So you can put all of that logic. For example, instead of calling the payment process payment over here, you can just call it in the UI. So you'll have an enter CVV. As soon as the user enters, let's say 250, you click on enter and execute this thing. So all of that logic can be done. I'm not focusing on the logic that much. I'm focusing on the design part. And this is how you would design the code. Now, just to recap whatever we did here, earlier we just had a factory method pattern. So we didn't have any of these factory things created. All we had was this payment processor, and we had understood why we need that. Then I decided to add an abstract payment factory. Why did we need that in the first place? That's because I wanted to add the logic for the UI. So I wanted this UI to show up. Let's say if I also wanted the logging part, and the logging should be different for, let's say, credit card, PayPal. For example, in credit card, you want to store to one database, but in PayPal, you want to store to another database. The logic for logging will be quite different in each one of them. So there'll be different methods created. The reason we could not put that in payment processor is because the job of payment processor was to just process the payment. It has nothing to do with the UI. So we could not burden this with the UI. That's why we decided to create an abstract factory. And what this abstract factory does is that it's kind of like an orchestrator. I think that's the best way to describe it. It essentially delegates each of the tasks just like a high-level supervisor would. So if we have a credit card, we'll just call the credit card payment factory, which is this part. And in this payment factory, we have two types. We can either create the UI, which is this part, or we can do the actual processing. So the factory methods that we had created are hidden from the client now. The UI, which is this part, the payment screen, it doesn't know about the existence of factory method. Now it knows about the existence of the abstract factory. And from that abstract factory, which is like a super class, you can call anything you want. So if you want to add logging, you can add another function over here and well, that's done. Again, one thing I would like to remind you is that it would be a good thing to create another class for the UI. Don't directly do the UI over here. You might want to create a separate class for the UI and then you can have as many methods as you want. For example, you want a different loading indicator for Apple Pay, or you need a different type of form. All of that can be changed from this class. The reason I'm saying this is if we just create a different class for this, we'll be following the O in solid principle, which is the open close principle. We need to be open for extension, close for modification. So we want to add a new feature, but we do not want to modify this class. I mean, think about it. Why should Abstract Factory care about how the UI is implemented? To give you an analogy, why would a CEO care about how you're designing the button? The button should just be designed, right? CEO can just see the work you do. They don't care about how you're implemented, and they're not going to change how you're implementing it. They're just going to tell you this is how I want it to be implemented. The same way over here, this supervisor should not care about this implementation. It should be done in a separate class. That's the good code part I'm talking about. So having understood that, I would like to remind you about the definition again. Abstract Factory means to provide an interface for creating families of related or dependent objects without specifying their concrete classes. So our interface, which is the Abstract Payment Factory interface, is used to create families of related objects, which are the payment processors, which is the payment validation part, without explicitly specifying and using their concrete classes. And that's what we have done over here. Now, what are the pros of using this? The benefit of using this Abstract Payment Factory is that it allows the client code and payment screen, the screen that actually displays all of this, to remain unaware of the concrete classes, relying instead on the factory to provide the appropriate objects. This ensures that the new payment methods can be added easily without altering the existing client code. So this benefit is quite similar to the benefit we have already talked about for factory method. It's essentially the O in solid principles, which is the open close principle, and I talked about it. It also ensures that objects from the same family are used together, promoting consistency. So everything is found in one place, and that's good for us. Now, what are the cons? The cons are that this pattern, again like factory method, introduces additional classes and abstractions which can lead to more complex code. And as you can see, it's quite complex code just to do these things. You can do all of that in just the UI of payment screen, but it would just be messy. It would be a hard time for you to change your code and add new features. With this, it's quite deterministic. We just have to add another processor to do a processor. We just have to add another payment factory and we do the payment factory. So all of that is quite helpful, especially when you're working in a larger code base. There might also be another con if this is not implemented properly, and it is that if there are many product families, the concrete factories may end up duplicating a lot of code across the families, as the structure for creating similar objects might be repeated, leading to duplication in the code base, and you don't want to repeat yourself, right? So that's something you need to be aware of. Not duplicating a lot of code, but it can happen that you ultimately have to duplicate a lot. So that's one con. And this is the diagram of what's happening throughout this entire code base. So we have a payment screen which uses the payment method enum, that's unchanged. Then it also uses this abstract payment factory, and this abstract payment factory has three classes that implement it: the PayPal payment factory, the Apple payment factory, and the credit card payment factory. Now these three things create their own things. For example, the credit card payment factory creates its own credit card processor, the PayPal payment factory creates its own PayPal processor, and Apple payment factory creates its own Apple Pay processor. Now all of these three processors are implementing the payment processor defined over here, and that's the factory method pattern, alright? And the payment screen also uses the payment processor, but it's kind of indirectly, because if we go over here, the payment screen has a processor. It creates a payment processor. It doesn't know about the underlying implementation, but it does use the processor. So yeah, that's the entire code. If you see on a high level, the payment screen has to talk with the abstract payment factory, and that's the biggest thing. So yeah, that is it about abstract factory. Now the next design pattern that we're going to take a look at is builder. Now I just want to say it from the very start. Builder is not used that often in Dart or Flutter, and the reason for that will be understood. And the entire explanation is going to focus on why we do not use builder pattern in Dart or Flutter. So let's get into it. So what is the definition of builder pattern? Builder pattern means that we want to separate the construction of a complex object from its representation so that the same construction process can create different representations. What does that mean? Well, let's take an analogy and then we'll directly convert it into code. So you can think of builder pattern like a custom sandwich shop where you as a customer are guided through a step-by-step process of creating your perfect sandwich. When the shop provides you with a menu with various options for bread, meat, cheese, toppings, you make your selections. The chef will assemble your sandwich according to your specifications, and this will allow for great flexibility in creating complex object. What is that complex object? The sandwich. And you can have different representations of that sandwich using different ingredients and different combinations using the same construction process. So the way a sandwich is created remains the same, but what you put in there changes. That's what the builder pattern is about. This is the code that we have for the builder pattern. I took the liberty of just writing it all together because we don't use it that often. So I just wrote it out over here, but we'll see what we actually use in Dart or Flutter over this builder pattern. So let's say we have a sandwich builder. The sandwich builder is like the chef. So we have a class of sandwich builder. They have the bread, meats, and a boolean value of do you want extra cheese or not. Then we have an immutable class of sandwich where again, we are going to take the bread, meats, and has extra cheese, but we're going to take it from the constructor. And we're taking it from the constructor because the user has to specify it. Now let's say this is the user. The user creates a sandwich builder, puts in the white bread, says that they're not going to eat any meat, they're vegetarian, and they want extra cheese. Who doesn't love extra cheese? And let's just say they verify that the sandwich does not have any meat. And when you run it, you get an empty list. Because here we have put the logic that meat is going to equal to builder.meats if it's present. Otherwise, if it's null, it's going to be an empty list. So we do get out an empty list. And that's what the builder pattern is about. Remember the definition again. Separate the construction of a complex object, which is this sandwich, from its representation, so that the same construction process can create different representations. The benefit of doing this is that the sandwich class can remain immutable, and there's a class called sandwich builder which we use to change the properties of sandwich class. Now, if this was immutable, we could not change the bread property over here. So we could not do sandwich builder dot bread is equal to white bread because it's immutable, right? But what we have done is created a sandwich builder taken through the constructor, which is mutable. So these values can change. These values cannot. So sandwich builder is used to change the properties of sandwich that helps us create different representations like a cheesy sandwich, chicken sandwich, or whatever else exists. Another benefit of doing this is that we do not have to type in dot meets is equal to null. As you can see, I've put a comment not required to be typed. If you remove this and run it, it will still work the same way. You don't have to specify, let's say this has extra cheese as well. It will figure it out all on its own because you can always have false over here. So from the client side, they don't have to specifically say that, hey, I do not want cheese. They can just omit it and well, it will work out, right? So if I go ahead and type out has extra cheese, and then I'll also add false over here. So if the user doesn't mention anything, it's always going to be false. We can run it and we get false written out. And as soon as the user goes ahead and adds dot has extra cheese is equal to true, well, we can run it and it will default to true. So these are the two benefits, but wait a minute. If we only have these two benefits, why do we have to go through the extra class? Isn't that unnecessary? We can do it with just one class, right? And you're not wrong. We can just do it with one class actually. So this is the reason why builder is not used. We can just remove it. We do not take this builder from here. Instead, what we're going to do is have a constructor and have required this dot bread, required this dot has extra cheese, and then we can just say this dot meets is equal to empty list. So if the user doesn't specify anything about the meats, we are going to assign it a default empty list. If you want, you can do the same thing for has extra cheese as well. And here you can have all of these values as non-nullable. Now you can alter this however you want. Maybe you want bread to be nullable. I don't know, you can create a sandwich with just cheese, who knows? So yeah, all of these things can be done. Now you have a sandwich constructor like this. You don't have to go through the burden of this sandwich builder and passing that builder in to the sandwich. So if you want, you can create your veggie sandwich like this, right? You have sandwich. Let me just take this. And in a veggie sandwich, what do you need? Well, I would need a whole wheat bread. I'm a very healthy guy. And to compensate for that healthiness, I'll add extra cheese. And there we go. So we have a veggie sandwich. Now what if I want to change this veggie sandwich so that I have a chicken sandwich? How can I alter this sandwich? Well, I cannot directly just go and do veggie sandwich dot, let's say, bread is equal to white bread. I know that's not what differentiates a veggie sandwich from a chicken sandwich, but yeah, let's just say I change it to white bread. We can't do that, and that's because we have set this as final. Since it's final, it's immutable. We cannot change it. So what can we do instead? Well, we can just create a function called copyWith inside of the class. So what we can do is, in this copyWith, we can return a new sandwich class instance that will create the object by just changing one property. Stay with me. So I'll just have sandwich copyWith. It's generally called copyWith, but you can just name it anything you want. If you've followed other tutorials of mine, you know an extension in VS Code creates this, and that is called the Dart data class generator. That's exactly what we are doing, but this time we're typing it out and understanding. So we are going to take in these things which can be null. So we have a list of string which can be null, and then we'll have a Boolean value which can be null. Now what we are doing here is that we're creating a new sandwich class. Remember, we have an immutable class. We cannot change its properties, but what we can do is return a new class So we can just have bread, and if the bread from the constructor is present, we're going to use that. Otherwise, we're going to use this dot bread, which is the bread defined in this class. Okay. And the same thing goes for this meats. So we're going to have meats, and if it's not present, we're just going to use the meats present in that class. And finally has extra cheese. And there we go. Now you might be wondering what's the benefit, and now I'll show you the benefit. Let's say we have veggie sandwich. Now I want to add a chicken sandwich. So what I can do is veggie sandwich dot. Now I have access to this copy with function. I'll use that. I have access to this copy with because we are essentially having a sandwich class, right? This veggie sandwich is an instance of sandwich class. So we have access to this copy with function. I'll use this copy with function, and everything is going to remain the same. Let's say the bread is same. We have extra cheese, but this time we are adding meat, and the meat we are adding is, let's say, chicken. I don't know if chicken is considered a meat, but yeah, we can store that in chicken sandwich, and that's it. Now I'll take this and print it out. So we have print chicken sandwich dot meats, and that's it. I'll also print out veggie sandwich dot meats just to show you the difference. Let's print this out. So we'll run it, and we get an empty list in the first try, chicken in the next one. So there we go. This is the pattern we use in Dart or Flutter. We do not use the builder pattern because we have such nice techniques. Ultimately, the benefit of this is that you can create another instance with the same attributes, but you can also change the attributes if you need. While these properties are immutable. So these properties cannot be changed. Veggie sandwich properties cannot be changed once they are there. The same goes for chicken sandwich, but a new class can be created from one function, right? So that's about the builder pattern. This is why it's not used. You can see the difference between builder pattern and this pattern, whatever it's called, I don't know. If you want to see a practical implementation, you can watch any of my project videos. I've used this copy within almost every single one of them. It's quite helpful. Now, having understood the builder pattern, let's go to the final design pattern in creational design patterns, which is the prototype. Well, what is the definition of prototype? Well, it's quite simple. Prototype means to specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. To put it more simply, prototype is cloning. Well, we're not going to use an analogy for this, don't worry. It is fairly straightforward, and we've already seen a glimpse of how we can do this in builder pattern. Let's bring back our sandwich example. I think we are already quite familiar with it. I just discussed it like a minute ago. To follow a design pattern of prototype, all we have to do here is create a new method called sandwich. So we're going to return a new instance of this class. Let's call it clone. And then we're just going to return the copy with from here. And we're going to pass in the bread as bread. We're going to pass in the meats as meats. And finally, we're going to have has extra cheese, has extra cheese. Well, that's it. This is cloning. What we have done is use the copy with function, which is this one, to return a new class of sandwich. And we've just passed in the attributes over here. So if we do veggie sandwich dot clone, we are creating a new instance of sandwich with the same attributes, the same bread, the same has extra cheese, same everything. So let's say I have a friend who likes my veggie sandwich because my choices are so great. You know what I can do? Sandwich2 is equal to veggie sandwich dot clone. And there we go. My friend and me are going to have two veggie sandwiches that looks the same. But remember, it's going to be two different sandwiches because I'm not sharing my sandwich with a friend, right? That's what this does. Now, if you want to confirm that these are two different objects, what we can do is print veggie sandwich 2 is equal to veggie sandwich. If they were the same object, they should be true. If they're not, it's going to return false. And we do see false because these are two different sandwiches. We have cloned a sandwich. We have not given the same sandwich. It's not the same instance. It's not the same anything. So what we had done is, let's say this was our sandwich1 class. We are not sharing the sandwich class by two people. Let's say I was using this. Now it's not like another person is also using it. No, that's not happening. What we have done is created another sandwich class which is being used by another person. These are two instances, not the same instance being used by two people. So that's what cloning does. Well, what are the pros of it? We are creating a new object by copying an existing one. And that is often faster than creating one from scratch, especially when the object has expensive initialization steps. We just have a sandwich, that's easy. Let's say we have a class which on creation connects to some database or connects to some file system, has some network resources. If we create that new object, we'll have to go through that process again. But when we clone it, we don't really have to go through that, I guess. Also, by using a prototype instance, the need for subclassing can be reduced, as you can create different configurations of an object without creating separate subclasses for each variation. So you don't have to create a sandwich class as an abstract interface, and then you have a chicken sandwich which implements that sandwich class and changes the bread. Then you have a veggie sandwich which implements that class and changes something. You don't do all of that. All you have is these things and your logic works perfectly. Subclassing, creating multiple classes, all of that gone. This is easy. The cons are that the prototype pattern is most effective when object creation is costly or complex. In scenarios where object instantiation is simple or performance is not a concern, using this pattern may probably introduce unnecessary complexity, but I don't think it's that complex, to be honest. And the second one is that, well, it's not a con, it's more about you need to be careful while implementing the prototype pattern. And that is dealing with complex objects that can have nested or reference type attributes. A shallow copy can be created. Let's say you have a sandwich class which uses another class, and that class is using another class. So be careful if you have class after class and you've not deep cloned it. If you've just shallow copied it. A shallow copy may give you quite a few logical errors. It won't really give you syntax errors, so it will be hard to figure out, or your application will behave differently from the way you expected it to. Make sure you do a deep copy. Even in our case, when we have a list of string, it can be problematic because it uses reference type. And when it's a reference type, it means that if I change veggie sandwich to have one meat, veggie sandwich 2 will also have that meat, and you probably don't want that. So what you'll have to do is deep copy this as well. In our case, we cannot edit the veggie sandwich from outside because it's an immutable class, but it's something you need to keep in mind. So yeah, it can be quite tricky. You need to understand what reference type means. It means that this list can be updated from outside. So you can do veggie sandwich.meats.add, but the only reason we're not doing it is because we have @immutable and it will give us an error. But that's something to keep in mind. And the problem I'm describing is that, let's say the meats was empty, but here in the veggie sandwich one, we add chicken. And since the list in the sandwich 2 depends on this list, it's not really a new list. The veggie sandwich 2 is a new instance, but the list property maps to this particular thing. It has a pointer to this meats list in the veggie sandwich class. It's not a new list. So if you change over here, this will also change because it's ultimately pointing to the veggie sandwich class. It's not a list of its own. So what you want to do is create a list of its own so that if you change stuff in your sandwich, your friend doesn't have to change it. Maybe you decide to become non-vegetarian, your friend still is vegetarian. So yeah, a good thing to keep in mind. Now, quoting from the Gang of 4 books, prototype and abstract factory are competing patterns in some way. They can also be used together. However, an abstract factory might store a set of prototypes from which to clone and return product objects. Let's break this down. How are they both competing? So both patterns aim to abstract the creation of objects. The competition arises when deciding how to instantiate an object. Do we want to clone an existing instance, which is the prototype, or do we want to delegate the instantiation to a factory method, that is abstract factory? So this is how they're competing. Now, how can they be used together? Well, let's say we have a class just like this. Well, this is the prototype pattern. And then we create an abstract factory interface. So what we do over here is, let's say, have abstract interface class sandwich factory. And in this we have two things. We create veggie sandwich, and then we have create meat sandwich or chicken sandwich, whatever you want to call it. So this is the abstract factory interface. Now we are going to create a concrete factory using the prototype method. So what we are going to do here is have a class of prototype sandwich factory, which implements the sandwich factory. Then we are going to have a final sandwich with the veggie sandwich passed in over here. And then we are going to have a meat sandwich or meat prototype, whatever you want to call it. They're actually prototype sandwiches. So if you want to call it meat prototype, that's fine too. Then we can have a prototype sandwich factory, which is required this dot veggie sandwich required this dot meat sandwich. After this constructor, we can just create two missing overrides. And in this case, we are going to return veggie sandwich, or actually meat sandwich dot clone. So we return a clone of that particular sandwich. And then we also do the same thing for veggie sandwich. We have returned veggie sandwich dot clone. And now over here, when we create the veggie sandwich, we create the chicken sandwich. So these are the two sandwiches that we've created. Or if you have, let's say, a normal sandwich created like this, that's also fine. Both of them are fine. And now what we can do is create this prototype sandwich factory. So we have final sandwich factory, which is equal to prototype sandwich factory. And in this, we can pass in the veggie sandwich, which is this thing over here. And then we can also pass in the meat sandwich, which is the chicken sandwich over here. Then we can take this sandwich factory and create as many veggie sandwiches as we want. So we can just have final veggie sandwich 2. Let's say I have 3 friends who like this veggie sandwich I eat. So we can just do sandwich factory dot create veggie sandwich. And you can do this as many times as you want. You'll always get a new instance of the veggie sandwich. And the same thing goes for the chicken sandwich. So you can create as many chicken sandwiches as you want. So this is how you can use abstract factory and prototype together. You might be wondering, like, why do we need all of this? This is just additional work. And you're kind of right. This is additional work, but the benefit you get here is that all of the logic has been compressed into one class. So the cloning part, all of that part is done over here. All you have to do is specify that in this prototype sandwich factory, you always get sandwiches that look like this. And you can then have another class, which is, let's say, production sandwich factory. In production, maybe you do lesser experiments. Maybe you have more variety. You can support all of those use cases and expose that to the client side. So there are benefits to it, but yeah, if you want, you can just use .clone, but I would generally recommend creating a separate class and doing all of that. If it's a complex project, if it's a simple, it's quite easy. You can just do whatever you want. The core of design patterns is that you need to optimize for many engineers working on it and make the addition of new features very easy. And to do that, you need to combine solid principles. You need to combine these design patterns. They're quite intuitive if you think about it. Like, they're a good way of going about it. But if you understand the core, you can understand of when you want to use it and when you want to break it. These are not hard truths that you always need to follow. Your use case can be different. The core is understanding this truly and then using it in your projects. And once you get an intuition, knowing when to not use them, and if you want to possibly break them, then use it. So yeah, this is the end of creational design patterns. To revise, they were creational design patterns because each of them dealt with object creation mechanism. We started with Singleton, which was about creating one instance. Then we had factory method and abstract factory, which was about creating multiple objects together. Builder was about creating a complex object using the same construction process. And prototype was about creating a prototype instance or cloning the object. All of that dealt with creation of objects, trying to create objects in a manner suitable for the given situation. And that is the end of creational design patterns. In the next video of this series, we'll get into structural design patterns, and part 3 will be behavioral design patterns. So thanks for watching, and I'll see you in the next video.